Hello everybody. In this video session I am going to talk about the coursework. You have to design the suitable interface diagram to interface TM1637. It's actually a 7 segment display driver IC. This you have to connect to the 4 7 segment display and write a single program to perform this following task. The display is available as a standard module with us along with our group based board, and it has a IC, and you may notice here we have 4 7 segment display. If you look at the 4 7 segment display, basically it has about 12 pins in the module, like 3 plus 3 is 6, and here 12 pins. If you connect these 12 pins to the microcontroller, first of all the number of IO lines is going to be very high. So we use this display driver. This display driver will take care of putting the message in each segment and also multiplexing. That means to save the power. Only one segment will be turned on at the time and the data will be sent to this segment. This particular IC will do all this function. What we have to do is we have to send the data from the microcontroller to this IC through the serial communication, especially using a communication standard called I2C, or we refer as a IIC. Okay, now this is our base board. You will be connecting the display using the interface card in this socket, and you notice here this is pin number 9 and 10 of the launchpad, which will get connected here, and we are going to connect here a variable resistor also, potentiometer. Okay, so if you connect these two components over here, it is going to make the connection something like this. So pin number 9 and 10, which is nothing but serial clock and serial data, and we have other pin numbers. This is nothing but pin number 23 and 24, which is nothing but we have here 21, 22, 23. This is 23. Pin number 23 is nothing but channel 0. So this is the baseboard pin out details. So once you interface the 7 segment display, which get connected to the pin number 9 and 10 along with the VCC and ground, and if you interface the variable resistor which gets connected to channel A0. Now what you have to do, you have to write a C program to test the 7 segment display with the typical test pattern. That means when you run your program, first it has to show in all segments like 999 and the delay, then it should change to 888, then 777. It goes on like this up to 0. Once this has been done, you have to read the value from the ADC channel 0 and display it on the 7 segment display. If you configure in 12-bit mode, we will have the value from the potentiometer to 0 to and the maximum value 4095, which need to be displayed on the 7 segment display. And also you have to develop the C function, or you have to alter the C program which you have done in the step A and B to show as a status. So what is the meaning of status here? You have to reflect based on the value which you get from ADC. You have to turn on the LED 1 and 2. If the ADC value is going to be from 0 to 100, you have to turn on red LED and green LED must be off. If the ADC range is from 100 to 4000, both LEDs must be on. If the ADC value is from 4000 to 4095, the green LED must be on. This you have to reflect on the LEDs, the status. And you have an option here to choose LED or 7-segment display. Of course, if you implement using 7-segment display, it will be considered as a a higher challenge which you achieved. If you implement both of them in a single program, which is considered as your honest challenge, which you are addressed. What you have to do with the 7-segment display? In 7-segment display, if the ADC value is from 0 to 100, you have to show as a low. From 100 to 4000, you have to show it as a medium, and from 4000 to 4095, you have to show as a high. So this task you have to implement using 7-segment display interfacing. Once you implement this task, if you have noticed, we will be using here a software delay between each step, and we will be using here ADC in a poll mode, okay, to read the result. And again we will be using the switch again in a polling mode. So what you have to do is, in a interrupt task, you have to use any one of the interrupt system. It's not mandatory you have to use all three of them. You have to implement either the hardware delay using timers. This can be achieved using timers instead of having software delay, or you can use a ADC conversion again based on the interrupt instead of using in a poll mode, or you can also use external interrupt to read the push button status along with the debouncing routine. Okay, so this task which you can implement. In the next video, I am going to talk about the data sheet of this IC and the basic code which is given for this IIC protocol, plus a simple program how to make a 7-segment display data, and also the specification document. Just let us see the demonstration of the result, what is expected from you. You can see I just downloaded the program. If you observe now, this is your starting point of your program. When you run the program, first the display should show the standard test patterns. You will observe that it starts from 999 and goes up to 0. Okay. Soon after that, it reads the value from the analog to digital converter channel 0. That means where we connected the potentiometer, and then it displays the equivalent value. And as I specified earlier, if the value up to 100, a red LED should be on. If it is from 100 to 4000, both the LEDs are on. And if it is from 4000 to 4095, the green LED must be on. So let me vary the variable resistor now, and you will see here it reducing the values, and if it falls below 100, you can see the red LED is on. So same way, if I increase it again, and you can see that both LEDs are on, and if it comes to the range of 4000 to 4095, you can see the green LED is on. Or you should be able to choose this one, the option, through the 7-segment display. So basically you have to implement either the LED or 7-segment display. As I mentioned earlier, if you implement using 7-segment display, which is considered to be your achieved honest challenge. And if I change that, you can see the LED goes off now. Based on the input value from the potentiometer, the 7-segment display will show only 3 status: low, medium and high. So it is right now at I, and this is medium. So when I reduce it, it goes to low. So there are 3 status which has been displayed on the 7 segment display: low, medium and high. So again, if you click on this, again it will get back to the display value here. Okay, so again if you change on the potentiometer, it will show the status on the LED. This is a task which you have to implement in your coursework.